All right, so what if we want to multiply and divide imaginary numbers? All right, let's look at how we could do that. So if we have 3 plus 7i times a negative 11 minus 2i. I is not a variable, but you can treat it like one. So if you had 3 plus 7x times negative 11 minus 2x, what would you do? Well, you would FOIL, right? So we're going to do the same thing. So we're going to say 3 times negative 11 is negative 33. And then 3 times negative 2i is negative 6i. 7i times negative 11 is negative 77i. And 7i times negative 2i is negative 14i squared, because a positive times a negative is a negative. 7 times 2 is 14. I times I is I squared. All right, so we have like terms here in the middle. Again, just as if you had a negative 6x and a negative 77x, you could combine that to be a negative 83x. I works the same way. Now, we have talked before about the fact that I is the square root of negative 1. We discussed that in the last video. So if we square I, we square the square root of the negative 1. You can see that the square root and the square would cancel each other out and just give me negative 1. So I squared is negative 1. All right, so when I have negative 14i squared over here, I can simplify I squared to be negative 1. So now negative 14 times negative 1 is positive 14, and I can combine that negative 33 and the positive 14 to be negative 19. When I give my answer, I want to give it in standard form, which is a plus bi, so a plus bi. Now, we also could check that on our calculator. In our last video, we talked about how we could do imaginary numbers on our calculator after we switched it from real mode to imaginary mode. And you can see how the calculator is verifying for us that that's the correct answer. Now, what if we wanted to look at some higher powers of I? All right, we said that the square root of negative 1 was I squared was negative 1. So what if we had I cubed? Well, I cubed is just I squared times I, right? And we said a second ago that I squared was negative 1. So if I squared is negative 1 times I would be negative I. For I to the fourth could be I squared times I squared. And again, since I squared is negative 1, that'd be negative 1 times negative 1, or positive 1. For I to the fifth, we could just take the answer we just got for I to the fourth and multiply it by I. So I to the fourth was 1, so 1 times I is just going to give us I. For I to the sixth, we could take the answer that we just got for I to the fifth and multiply it by I. So I to the fifth, remember, was I. So if we take I times I, that's I squared, or negative 1. For I to the seventh, we can take the answer we just got for I to the sixth and multiply it times I. We just got negative 1, so multiply that times I, and that'd be negative I. And we could just keep going and going and going with this, right? So something that you'll notice about this is that we start getting that feeling of deja vu because this has a pattern. It repeats. If you'll notice, we could go back and say, we started with I to the first, but if we went back to I to the 0, I to the 0 is 1. Anything to the 0 power is 1 except for 0. So you can see the pattern here. 1, I, negative 1, negative I. 1, I, negative 1, negative I. 1, I. And it's just going to keep repeating that that pattern of 4. So if I want to find something like I to the 252, I could sit here and count these out over and over and over again, but there's a faster way to do that. If I take that exponent of 252 and I divide it by the pattern of 4, that tells me you're going to get 63 of those complete patterns with a remainder of 0. That remainder can become my new exponent. So what I mean by that is that I to the 252nd will be the same as I to the 0. My remainder becomes my exponent. All right, then I to the 0, of course, was 1 right up here. Let's try another one of those. Look at I to the 133rd. All right, if we take 133 and we divide it by that pattern of 4, we'll get 33 remainder 1. So that remainder of 1 becomes our new exponent. And so I to the 133rd would be the same thing as I to the 1st. And I to the 1st, of course, is I. Okay, I guess, but how do I really know that works? Okay, let's come back up here and let's look at like I to the 7th. We reasoned that one out, right? So if we take 7 and we divide it by 4, 7 divided by 4 would be 1 with a remainder of 3. My remainder should be my exponent. So I to the 7th should be the same thing as I to the 3rd. Well, I to the 3rd was negative I, and I to the 7th is negative I. Do that same thing with I to the 6th. All right? If we have I to the 6th, 6 divided by 4 would be 1 with a remainder of 2. So I to the 6th should be the same thing as I to the 2nd. And sure enough, I to the 2nd is negative 1, and I to the 6th is negative 1. So again, when you divide, your remainder becomes your new exponent. All right, what about division? All right, if we are dividing with radicals, you can never leave a radical in the denominator. A radical in the denominator has to be rationalized. So just a reminder of how to do that. If we had 4 over the square root of 3, we have to get rid of that radical in the bottom, and the way we rationalize is we multiply by the square root of 3 over the square root of 3. Why do we do that? Well, because the square root of 3 times the square root of 3 would be the square root of 9. It would just be 3, so we got rid of our radical. And now in our numerator, we've got 4 square roots of 3. So when I have 4 over I is the square root of negative 1. It's a radical. I cannot leave it in my denominator. So just as we did a second ago, I'm going to multiply top and bottom by that radical. And so I'll end up with I times I in my denominator, which is I squared. And what's I squared the same thing as? Negative 1. So we'll have 4I over negative 1, which would be negative 4I. All right, look at the next one. If you have 2 terms in your denominator and one of them is a radical, you cannot just multiply by the radical. It won't fix your issue. As a matter of fact, it'll make it worse. Instead, you need to multiply by something called the conjugate. And in complex numbers, as we're working with here, it's called the complex conjugate. So I'm going to use the exact same numbers, 2 and I, 2 and I. I'm going to use the opposite sign. So the opposite of the negative is the positive. So that would be its complex conjugate. What you do to the bottom, you got to do to the top, right? So let's go ahead and multiply. In our numerator, I'm going to leave this alone for just a second, but let's go ahead and let's multiply our denominator, all right? So when we multiplied this a moment ago, we FOILed. So let's do that same thing. We're going to say 2 times 2 is 4. 2 times I is 2I. 2 times negative I is negative 2I. And negative I times I is negative I squared. So the 2I and the negative 2I will drop each other out. And then I squared, of course, is negative 1. So 4 minus a negative 1 would give us 4 plus 1, or 5 in the bottom. Now, the only reason that I haven't gone ahead and distributed this numerator is I was checking to see if by any chance I'd get something in the denominator that would cancel with it. For instance, if I had had a 4 in my denominator or a 2 in my denominator, I would have been able to cancel with that 4. I would have been able to simplify. But since 4 won't simplify with the 5, now I can go ahead and distribute. So 4 times 2 is going to give me 8, and 4 times I is going to give me 4i. Now we need to give that answer in standard form, and standard form is a plus bi. So instead of having this combined over a singular denominator, they want me to break it back apart. So I've got 8 over 5 plus 4 over 5 times I. 8 over 5 plus 4 over 5 times I. Then it's in that a plus bi form. All right, look at one more of those. So this time I have 1 plus I in my denominator. What would my complex conjugate be? It would be 1 minus I, so I'm going to multiply top and bottom by 1 minus I. I'm going to leave the numerator alone to see if I could cancel anything in a minute. So let's work on foiling the denominator. So 1 times 1 would be 1. 1 times negative I is negative I. I times 1 is positive I. And I times negative I is negative I squared. So the positive I and negative I drop out, and remember that I squared is a negative 1. So 1 minus a negative 1 is going to give me 2 in the denominator. Is that 2 going to cancel with anything in the numerator? No, so I might as well go ahead and distribute. 3i times 1 is 3i, and 3i times negative I is negative 3i squared. All right, what is I squared again? It's negative 1. So if I have a negative 3 times a negative 1, that'd be a positive 3. And then last, I want to break that apart to write it in standard form, a plus bi. All right, the last thing we want to look at is how you can graph imaginary numbers. You cannot graph something imaginary on the real number line. So instead of working with our normal Cartesian plane, the x and the y axis, the only way that we can graph imaginary numbers is if we are on the complex plane. And the way we can see that is in the complex plane, the x-axis is the real axis and the y-axis is the imaginary axis. So this does not work in a typical Cartesian plane rectangular coordinate system where we have a horizontal axis of x and a vertical axis of y. Our horizontal axis has to be the real axis and our vertical axis has to be the imaginary axis. So if you have something a plus bi, remember this is the real part, this is the imaginary part. So we'll want this to graph on the horizontal axis, like where we'd normally put x. And we'll want this to graph on the vertical axis where we would normally put y. So our ordered pair, instead of it being xy, is going to be real imaginary. So if I have something like 2 plus 3i, all I need to do is pull out the 2 and the 3. That's going to be my ordered pair. And then I can graph that exactly like I would a normal point. So I can come over 2 and come up 3, and that would be the graph of 2 plus 3i. All right, look at the next one. If you have 4, what is that? 4 plus what I? Well, it's 4 plus 0i, right? So what would that ordered pair be? 4, 0. And so to plot that, I can come over to 4, and I'll be at 4, 0 for that point. How about the next one? What is this? Well, this is 0 minus 3i, right? So that ordered pair would be 0, negative 3. And to plot that, it would look like this. Now, if you'd like a few extra problems just to practice with, here is some classwork that we did together. And if you want to pause the video right now and work on those and then unpause it, you'll have the solutions.